So this video lesson is meant to help you understand the basics of something in chemistry that is called percent yield. And to understand percent yield in chemistry, it's really like evaluating your test score. So let's say you had a test that was worth 60 points, and the maximum score he or she could theoretically get is 60 points, right? But let's say the student actually gets a score of 30 points. So the student did not do terrifically well, but they got half the information, right? So you know that that percent score is 30 out of 60 or 50%. This can be captured in the equation of your percent score is equal to your actual score over your theoretical score of 60. And then, of course, multiplied by 100 to put it into percentage form. In a chemical reaction, there is a theoretical amount of product that can be made. This is determined mathematically by using stoichiometry and is called theoretical yield. So this is sort of an important piece so far, that the gram-to-gram stoichiometry that we've been working on is the answer to that problem, to that gram-to-gram stoichiometry. The answer to that problem is called the theoretical yield. So the theoretical yield is what the math of the chemical equation predicts you can make. Now, when the chemist actually performs that experiment in the lab, the amount of product that actually forms when the reaction is carried out in the laboratory is called the actual yield, or sometimes it's called the experimental yield. It's what you actually produce when you are doing the chemistry in a chemistry lab. And so the percent yield is the ratio of the actual yield to the theoretical yield expressed as a percent. Now, typically, percent yield should never be more than 100%. It is typically less than 100% due to several possible factors, including reactions don't always go to completion, impure reactants that you started with, possibly means that there are competing side reactions that cause unwanted products to form. When you're filtering, sometimes you lose product due to transferring or through the filtration process. Maybe the filter paper doesn't catch it all, or you don't get all the product onto the filter paper, or some is left behind in the original container. Or perhaps there are careless measurements of reactants or products. One reason why percent yield could be greater than 100% is due to contamination or impurity of the product. So substances other than the desired product are mixed in. We're trying to thoroughly wash the product to avoid this problem, but that doesn't always prevent a percent yield greater than 100 happening. So let's take a look at a couple of problems that you might come across. So what we have here is in problem number 1, using stoichiometry, you calculate that you will theoretically get 300 grams of a product. So they're kind of tipping it off here that this is your theoretical yield. It's theoretically how much you can make. But you actually only get 213 grams of the product. So this is set up pretty straightforward. Percent yield is going to be your actual over your theoretical times 100, right? And so the actual here is 213.0 grams divided by the theoretical of 300.0 grams times 100. The grams are going to cancel, right? And if we do this math in the calculator, we are going to see, maybe you can see, I'll do it right here. So 213 divided by 300 equals this, multiplied by 100 to put it into percent form, and we get 71%. So the percent yield is 71%. All right, let's take a look at one more problem here. In this case, the percent yield is being given to you at 75%, and the theoretical yield is being given to you at 18 grams. We are actually trying to find the actual yield. All right, so in this case, when you are given the percent yield, we are going to start with 75.0 And because it's percent, that means it is over 100. Okay, 75% is just 75 over 100. So that's our percent yield. And we're going to set that equal to our actual yield is going to be our X. We don't know what that is, but our theoretical is given to us at 18.0 grams. So here we have two fractions set equal to each other. So here is where we will cross multiply, right? Cross multiply. And so if we do that, we are going to get 75 times 18. That's going to be equal to 1,350 grams, because this 75% had no unit, neither does the 100. The only unit here in this problem is grams. So we should have that unit of grams there. And that's going to be equal to 100, and I'm going to set our actual yield to X. Solving for X, we need to divide by 100. And so 1350, let's divide that by 100. And we're going to get 13.5. So here, 13.5 grams is our actual yield. And this should make sense. Our theoretical yield was 18, so our actual yield, we knew the percent yield was 75%, so we know it's going to be less than our theoretical, and is definitely less by about 25%. So, all right, there are some example problems. There are 3 problems on this problem set, so this is a relatively short topic. We'll be advancing into more advanced percent yield problems in the next lesson. All right, check your work, and let me know if you have any questions, and I'll see you back in the classroom.